Good afternoon. I'm Jadira Rodriguez, manager, R plus D project manager of the waste department of FFSC Medio Ambiente. First of all, I would like to thank the organization for inviting us to share this in collaboration with the University of Valladolid and the Department of Sustainable Development. That is about, the hydrogen from the organic fraction using, the urban solid solvent waste with selective collection through the dark fermentation based on the lactate. In this presentation, first of all, we will see the role of FFC and BIDO and the environmental sector. Then we will show you some general aspects of the eclosion project. Then I will explain the fundamentals of the production of the hydrogen through the dark fermentation using lactate, and then the results at laboratory scale and also at the demonstration scale, and the treatment center of Valladolid, waste treatment center. And then we will provide you, disclose conclusions. FFCC Holdings environmental service of this company is represented at international level by FCC and BIDO. Has been delivering, their service from 2011. Over 78 million citizens were our clients who were present in more than 700,000 towns. A total of 27 million tons were treated, 2 million of which were processed in anaerobic digestion plants. We rely on more than 568 plants to remove waste and treat waste. The environmental services offered by FCC and BIDO are mainly collecting urban waste, daily cleaning, keeping green areas, treatment of waste, valorization of residues, energy valorization, and recovering soils. All the activities, FCC and BIDO activities, are held together in 4 platforms. According to the volume of business, go from bigger to the smaller. The Atlantic platform, which is made up of Spain, France, Portugal, and FCC Habitat, followed by the United Kingdom and center of east of Europe, and then finally the United States. FCC and BIDO commitment to the technological transformation of the sector is reflected by the number of initiatives, national and international initiatives, in which we participate as partners, but also as leaders. Among the most relevant projects, we might list, Zero Landfiller, which is focused on plastic chemicals, Prospero, which is focused on recycling bioplastics. Also, Abate, focused on mitigating volatile organic compounds and removing odor in these treatment plants, recovering raw materials, and also recovering material from the incineration ashes or remainings, creating groups, biomaterials such as prolignum or other products. And then the production of fuels, renewable fuels, and eclosion. Eclosion, whose title is New Material Technologies, a process for generation, storage, and integration of renewable hydrogen and biomethane from waste, was based on 6.6 billion budget and also subsidy for 4.5 million euros with 4 partners 10 different bodies, research bodies participated in this. The the project started on the 30th of June, and now the economic justification was completed. The objective, the project Eclosion is framed in the mission to boost safe, energy efficient, and clean. And the main object is to develop the new vectors, energy vectors such as hydrogen and biomethane. Solving, technological aspects such as the storage and reducing the cost of production. The specific objectives of Eclosion is developing new technologies and process to obtain hydrogen. Within these processes, we might name, the biological, electrochemical, and gasification processes. Second will be, gaining new materials to diversify technologies such as the synthesis of new membranes, ionic liquids or fluids, and design implementation of tools to generate, store, and distribute energy from bio waste. And then last, virtual integration of the solution, Eclosion, and the design of the energetic system. Our work is included in the first objective, and the scaling, development, and fermentation, dark fermentation process, and using, enriched bacteria for generating hydrogen. Now my colleague is going to explain further. Okay, I will explain further about the technical aspects. The dark fermentation, thanks to Maria, the dark fermentation is biological process with bioorganisms depending on pH, etc. It's an aerobic process with and at the same without light. These microorganisms decompose the organic matter, especially carbohydrates, with CO2, hydrogen, and also the volatile fatty acids. And there are also some alcohols and degraded materials, but not so many. This is a dark fermentation with lactate. But I would like to tell you that many of the problems, technical problems of this technology, such as the low performance or the unstable processes, low hydrogen productivity, has to do a lot with the zeolactic bacteria, because they are everywhere, and sometimes they remain in the fermentator and the process and cause all these problems. So this technology is about it's very easy to remove it with pre-treatment and following the indications, modifying pH and some parameters. It's very hard. It's very hard to remove it. So this technology take advantage of this presence. So instead of just fermenting the carbohydrates, a primary fermentation takes place. So this become lactate, lactase. This has a capacity to absorb the carbohydrates to become hydrogen. This began in the laboratory. We have lots of experience, wide experience in substrates, coffee remains, food remains, milky sectors remains, but especially the urban solid waste. We carry out different testing to investigate and study important parameters such as pH. And the first testing was based on optimizing this in a latent batch. Then we made continuous testing to find the pH and initial solid concentration values. This is more or less a presentation about it. So this is a parameter. The HRT is a parameter, a critical parameter to assure the productivity. This is one of the main production aspects. the productivity was quite high, up to 6 to 8 liters per day. So I would like to stress that this is about 5 to 15 times more than as reported by bibliography reference, for this type of waste. These are the experimental researching machinery, at the laboratory, devices, instruments to control the pH, to monitor the gas phase, the continuous process also to extract the substrate. And this is a comparison table. Include the obtained figures. Again, in different lots were used. So in the end, metabolism converged, and the lactic reduction is present. And these are some figures. And according to the type of experience, that goes from 8 to 17 liters of hydrogen of every 4 kilo. I would like to, which is OFMSW. So we were successful and obtaining that and to validate that part. Like a volume of 1 cubic meter with temperatures between 34.4 and 30.9. So there were other phenomena that took place represented at a small scale, but it might be different at this scale. These are performance were low. 32 liters per hydrogen and 20 liters of hydrogen of VS. So just to close up, to finish off, the technology LDDF for the production of hydrogen renewable has been validated at demonstration scale with promising results based on those properties. And showing or telling you another point of view, it might be there is a potential. Different testing can be done further in the future to validate this part. The plant is in Valladolid, 30,000 tons of OFMSW. So this is a complementary technology, of course. I didn't say it, but dark fermentation is complementary to the anaerobic digestion and other technologies, for example, for bioplastic, bio-oils, high aggregated content pigments. So it can actually be extended with a treatment plan to favor, the production organic matter. So there is lots of contained energy can be complementary in digestion plans. Thank you for your attention.